How we doing? We still awake? Got our afternoon coffee in, ready to go? Rad, all right, so let's get started. Security is in adversarial space. We all know that. We've been in the community for a while. And we know that our adversaries have objectives, whether they're nation state, whether they're financially motivated. Nation state might be collecting intelligence. E-crime might be obviously financially trying to gain financial returns. One thing that is, I think, not as often discussed is that our adversaries are also constrained in many ways. Similar to how we are constrained as defenders, they have budgets, they have people constraints, and they are always finding ways to maximize their ROI regardless of what their objectives are. And so we're in a new world now where generative AI, agentic tooling enables them to maximize their ROI in many different capacities. And so we are seeing adoption of this tooling in many ways. And so we're going to be talking about a bunch of what we're seeing and where I think we need to go as defenders to be prepared for kind of this new arms race. So I'm Josh Kamju, the founder and CEO of Sublime Security. We do email security. And so a lot of the insights that we'll be sharing today are from our in the wild kind of observations on what we're seeing adversaries adopt. So we're going to start with a evolution of how the landscape is evolving. We'll talk about what we're specifically seeing and how adversaries and which ones are adopting generative AI tooling. I think one thing that is often discussed as of late is how do we as defenders or the InfoSec community adopt generative AI for our defensive applications. But one thing that isn't as discussed as much is what are actually our constraints. How do we actually apply it? What use cases can we actually solve? So we're going to be talking a lot about that today and how we think that can be solved as an industry. So this is the new world that we find ourselves in. We have had the first two here for a very long time. So commodity phishing has always been, has effectively been high volume. It's customized, it's templated, I should say. Spear phishing has always been tailored. It's conducted by a human operator. It's very low volume. And then you've got Gen AI that is now the worst of both worlds here. It's tailored, it's high volume, and it adapts very rapidly. So it's the worst of both worlds. Google's threat intelligence group put out a great report recently on adversary adoption of Gen AI, and they specifically called out a few actors. One is Iranian APT and how they are using Gemini to craft phishing campaigns. Google has a really interesting vantage point because they own Gemini, and so they have all the telemetry around how that's being used, so they can attribute the actual specific activity to specific actors. So really interesting, something that we've been seeing on downstream on the email detection side, but here's Google giving us confirmation on the adoption by our adversaries. They also call out North Korean APT, leveraging it for researching advanced phishing techniques, developing malware, evading defenses. And they also call out e-crime, leveraging LLMs to augment business email compromise operations. And so I think that this is going to be the highest impact in terms of what organizations see, like enterprises see in the wild. E-crime today makes up most of the volume of phishing attacks, email attacks. But in particular, e-crime actors, unlike nation states, this very much lowers the barrier of entry for e-crime actors who historically have not had, translation capabilities on hand or interpreters on hand, and so it very much lowers the barrier of entry, and it allows them to make their attacks much more sophisticated, targeted, well-researched seeming. We're even seeing jailbreaks of LLMs that don't have any sort of defense mechanisms built in. So we're seeing this downstream on the email detection layer as well. So we're seeing this in our customer environments. I gave a talk on some of the more sophisticated stuff that we're seeing at B-Sides Las Vegas. And we've written about this at length at our blog as well. So if you're interested in seeing more examples, you can check out our blog. And we wanted to know, how quickly would it be to actually do this as an adversary? I'm an offensive guy. I spent my career in national security doing offensive cyber stuff prior to Sublime. And so this was fun for me to just kind of replicate as an adversary. How easy or how hard is it? And I can tell you that it's not very hard. So in about 15, 20 minutes, I'm able to give some prompts to ChatGPT, and it's able to generate a very timely, very targeted, seemingly well-researched, and perfectly grammatically correct phishing attack. So it's happening. It's real on the adversary side. What this means for defenders is that we continually, we're going to need more and more adaptive defenses, right? Because the threat landscape is going to be shifting. They're going to be finding new ways to evade. And so the rate at which we can adapt is going to be key. We released a threat research report kind of looking at our telemetry in Q1. And one of the observations that we seen in the data is that more messages are being more and more customized per recipient. So we've seen this gone up quarter over quarter. So it's happening in the data. We need defenses to be context aware, adaptable. So we talk a lot about kind of, as an industry, there's been a lot of talk about, agent this, agent that, use it for all these kind of defensive use cases. So this is what I like to call the security agentic AI trilemma. So I'm coining it here. You've seen it here first. If you see it out in the wild, I want to check in the mail. So the reality is, in terms of how this can be applied defensively, is that there are constraints. And you can only really have two of these three things at once. You can't have all of these three things today. You can't leverage agentic AI such that it is really fast in terms of like inference and verdict and rendering a verdict, and high efficacy and low in cost. It is only two of these. You can only have two of these three things at once. You could have something that's really fast, that's really cheap, but it's going to be low efficacy, right? And so what that means, given these practical constraints, is that the use case, what you're trying to solve for, is actually going to drive a lot of this, right? And so for email security and just like some use cases in general, it's impractical to be solved. So for any high volume, low latency, high efficacy problem, you can't directly use agentic AI to solve for today. And we wanted to break down some of these use cases that we as a security community are thinking about, and there's a lot of discourse about leveraging these capabilities for, and break it down into whether we think it's feasible or not today. And so on the left here, we have the real-time classification problem. So this is email threat detection. This is network threat detection. So super high volume, needs to be super high efficacy, and has to be very low latency, right? You cannot solve this directly with agentic AI today. Alert triage, this second category here, this is basically like our AI SOC, right? We're seeing a lot of discourse around this, which is relatively low volume. It does need to be high efficacy, and latency is not as important, right? Even today, if you have a tier 1, tier 2 analyst, mean time to remediation is not sub-second, right? It's tens of seconds or maybe minutes. And so this is actually feasible to solve directly today, obviously given the volume and kind of specifics. And there's a couple other use cases that we threw out here, may or may not be solvable today. So how do we solve this? Right? We want to design a system that's going to be able to rapidly adapt and keep up with the pace at which our adversaries are innovating. And so we think the key to this is a multi-layered system that can leverage feedback loops and learn over time. And so the way that we design Sublime is a two-layered system where layer one leverages a DSL, a domain-specific language. It's a language that a computer can speak effectively. And that runs over high-volume data. It's super low latency, it's super cost efficient, and it acts as a filtering layer to decide what should be promoted basically to layer two. And at this point, once you reach layer two, you're basically back at the alert triage problem, which we know is solvable. And then what we can do is we can have a feedback loop where upon a misclassification or triage of a verdict, we can feed back into layer one, we can update the logic, and we can autonomously improve the system over time. So what are some of the specifics here? So the DSL that we created is called message query language. This is what operates at our layer one. It's purpose-built for describing complex email attacker behavior. And this is ultimately the language that's used by our agents to improve and to investigate. And so this is an example of what the DSL looks like. So who here has used like Claude Code or ChatGPT to like write some code or like a signature, like a rule or something like that? Yeah, a few? Nice, okay. So this is effectively what we have created, but it's purpose-built for email detection, real-time detection use cases. We created a language that computers can speak, and it leverages kind of these table stakes enrichment functions, things like natural language processing, computer vision, risk scoring, behavioral analysis, all of these things that you really need in order to do detection well. And it serves at that layer one filtering mechanism. So once we pass layer one to layer two, we now have effectively our alert triage problem, which we know is solvable, where we can leverage agentic capabilities with full chain of thought reasoning for transparency. We use MQL as a way to further investigate messages and ultimately produce a final report. And so this is architected, so this is like fully contained within AWS environments, and the feedback we've gotten, this is like released to our customers, is that ASA is more effective than the human analysts at many of our customer environments. So it works, the feedback has been pretty rad. And this is what ASA looks like in product, where it's rendering a summarized judgment, explainability, there's full chain of thought on how it arrived at that decision for transparency, if and when an analyst ever wants to review it. And so you can think of this as an augmentation or even replacement for tier 1, tier 2 analyst use cases. And then in any scenario where it's uncertain, it'll escalate to a human for review. So the next and final part, when we start to get about the feedback loops, is ADE, where if you think about one of the key reasons why defenses today are not rapidly adaptable is because models are trained in a point in time, effectively, right? And we know that the target is moving. This is not like hot dog or not hot dog, right? Like the threat landscape is moving. And so you need to be able to retrain models as new techniques and things come to fruition. And so that retraining process is what is a lot of the reason why there's lag time. And it's a lot of the reason why it's a very one-size-fits-all approach when you start to get to deploying these systems at scale. And so ADE solves this problem because it can generate new layer one detection coverage autonomously, leveraging the same signals that our models have access to. So we really believe that this is kind of like the future of where the industry is going to need to go, not just for email problems, but for all kind of real-time detection problems. So at the end of the day, we think that this architecture is able to solve these real-time detection and prevention problems, but most importantly, be able to adapt autonomously as attackers adapt and keep up and move even more rapidly. So at the end of the day, adversary adoption of agentic capabilities still very nascent, right? I mean, we're still at the very beginning stages. I think that we are increasingly moving towards you got machines on one side, you got machines on another, and they're just dueling it out, right? And so as a community, as defenders, we got to be able to adapt rapidly. So yeah, that's all I got. We got some time for questions, I think. Yeah. What we'll do actually is we've got a booth. So 525, you got questions, you want to nerd out about this stuff more, I'll be over there.